All right, everybody, we're going to be looking at transformations today. So the idea of transformations is how we can take shapes and move them around without actually changing the shape that it is, meaning we're going to move shapes to form other congruent shapes. So things that are still the same, just in a different location or position. So starting out, I'm going to have you pause the video and see if you can go through and sketch in this little fish, Mr. Fisher, and draw what you think he would look like after each of these things is done in order. So first this happens, then this happens, then that happens. So go through and see if you can sketch in what you think happens to Fisher as he does those three things. All right. So hopefully that's something that kind of looks like this. That first he flips around, so he's looking left. So I need to take this picture of the fish and flip it around. So now it is facing to the left. And then he rotates 90 degrees to look down. So if I rotate 90 degrees this way, he'd be looking up. I need to rotate it down so he's looking downward. So you get this. And then it says he swims down towards the sea floor. So I just move it on down here towards the sea floor. And as silly as this little activity might seem, it's actually a pretty decent way of introducing the three main transformations that we need to look at. What's called translations, reflections, and rotations. So a translation is simply when you move. So this last one was an example of a translation where I just moved Fisher down. A reflection is where you flip something either across, or we can flip up and down as well. So that first thing was an example of a reflection. And then a rotation is obviously the one where, he rotated. So let's look at a little bit more technical terms of how we do this. So first, we have a new little fish buddy down here, and we have coordinates A, B, and C, or points A, B, and C at whole numbered coordinates. I tried to line them up so that we have nice whole numbers we can talk about. Well, the first thing we're going to do is take each of those 3 points, and we're going to translate or move the way that it tells us to. We're going to move down each of those points down 3 and to the right 5. So from this point, I'm going to go down 1, 2, 3, and over 1, 2, 3, 4, 5. So this is the point that was A. We call a point that has been moved A prime, which is just an A with a little apostrophe on it. So it's a little hard to see. I'll zoom in for this first one here. That is A prime because it is A after it has been transformed, after it has been moved. And then I'll just repeat the process with B and C. So both of these have to be moved down 3, and they're both going to be moved right 5. Well, 5's easy because we're at -5. So they'll basically just move down 1, 2, 3, and then over to the y-axis. So that will be C prime, down 3 and over 5. And B will go down 1, 2, 3, and over 5. So the origin will be B prime. And then we can trace in the rest of Fisher. Not perfect, but you get the general idea that this is the same fish after it has been translated down 3 and right 5. Now, a little bit of technical jargon here. This is going to get a little dicey, but we can describe transformations by saying what you do is you take any point, any xy coordinate, and you're going to change it. So this little arrow means that we're going to switch it so that, and we use this to describe how each of these coordinates changed. So all of our x coordinates, so this was like at -2, and now it's over here at 3. This was at -5, now it's at 0. This is at -5, now it's at 0. All of our x coordinates increased by 5, and that's because we went 5 to the right. It's not magic, it's just what we did. When you increase, you add. When you decrease, you subtract. So when we go down 3, that's our y coordinate. All of our y values will subtract by 3. So what this is, it's a technical way of telling people what happens to the points after your transformation. So in doing the transformation, this is how all of the points adjust. So it takes it from using like English words and writes it into a mathematical symbology or terminology. So, all right, let's look at another one. So we're going to get into reflections now. So reflecting, you want to make sure you look at what it is that you're reflecting across. A lot of times you'll reflect across one of the axes, either the x-axis or the y-axis. But sometimes they'll give you a random line and you have to reflect across the line. That's where things get a little trickier. We won't look at that too much, but know that that is a thing that we can do and it might show up at some point. So the same general idea holds that when we reflect, what we're going to look at is however far we are from the thing we're reflecting, we want to end up that far away on the other side. So if I'm reflecting across the x-axis, I need to look at how far each of these points are from the x-axis and just send them to the other side. So here would be A prime for this problem. B was up 3, so now I want it to be down 3. I'm not moving left or right this time because I'm just reflecting the vertical. I'm reflecting across a horizontal line, so I'm only affecting the vertical coordinate, the y coordinate. And then C was up 1, so now C is down 1. So that's A prime, B prime, and C prime. See if I can draw a little bit better of a picture of Fisher this time. Not really, but you get the idea. He just flipped across the x-axis. And so what happens there is we take all of our x, y coordinates. And if you notice, we didn't move left or right at all. The x coordinate stays the same. What happens is we get the opposite of our y coordinate. So instead of being up 2, now I'm down 2. Instead of being up 3, now I'm down 3. Right? So it just changes the y coordinate when you reflect across the x-axis. And similarly, actually see if you can pause the video and draw what you think the fish will look like after you reflect across the y-axis. All right, hopefully you got something like that where we just flip our x coordinates this time. So instead of being left 2, now I'm right 2. Instead of being left 5, now I'm right 5 for both of those, but it doesn't shift up or down. So what we do here is we just flip or take the opposite of our x coordinate without adjusting the y coordinate. So that's the idea of translations and reflections. Now let's look at the tough one. Yeah, that was the easy part. Here comes the tough one, is the rotation. So with a rotation, what you really have to do is think about, first off, what is it that you're rotating around? Most of the time, you're rotating around the origin, the middle point right there, 0, 0. So we're basically just taking the whole graph and we're going to rotate it either to the left or to the right. And you use the idea of clockwise. You have to think about the way that a clock moves its hands. They all go around this way. Right? Clocks move around like this. So if I'm moving clockwise, then I need to rotate it that way. On the next one, counterclockwise would be going the other way. We're going to rotate downward. So basically what we want to do is we're going to take this and it needs to end up looking like that. So this will be our x coordinate and this will be our y coordinate. And the fish is going to completely rotate around. So let's see if we can do that on the actual paper. So instead of being left 2 and up 2, if I rotate that, those numbers kind of switch, but they're actually both going to be positive now. However far over I was is how far up I'll be when I get over here. And however far up I was is now how far over I am, right? See how the up becomes the over when you rotate? So instead of left 2, up 2, when I rotate that around, A prime is now going to be at the point 2, 2. And these get a little trickier too. Instead of left 5, up 3, I'm going to be right 3, up 5. And instead of left 5, up 1, I'm going to be right 1 and up 5. So that is our general shape for Fisher. Which again, I can kind of confirm since I have a piece of paper here that I can rotate and see how he ends up looking when I rotate it at 90 degrees. That's what our shape looks like. And again, we get that, and this is where things get a little trickier because stuff switches. All of our x coordinate now becomes the y coordinate. So our x is now the y, but if you also notice, we were left, but now we're up. So it's actually the opposite of y is our new x coordinate. And whatever our x coordinate is that right? No, sorry. Oops. This one's the same for here. We were up 2, and now we were right 2. So those are both positives. Our old y is now just our x. It's the x that switches. because we were -5 and now we're +5. So our x coordinates change sign and turn into the y coordinate, right? If you got that, great job. You should be set for this chapter. If that doesn't make a lot of sense, try to at least make sure you understand how these things move and using the paper to kind of help you out with that. This is getting, like I said, very technical down here, so it's okay if you're not perfect at it. Let's see if we can go counterclockwise. So see if you can pause and just draw in what you think Fisher will look like after we rotate it 90 degrees down into this quadrant. All right, hopefully you got something that looks like this. If I take that picture and rotate it 90 degrees counterclockwise, so the fish is now looking up. It's at -2, -2, -3, -5, and -1, -5. So if I put that back and I sketch those in, I've got my A prime, B is now down here, C is down around here, C prime and B prime. And so what ends up happening is this is the one where, again, they switch, or X and Y switch, but it's the X coordinate that changes now. Where we were up 3, now it's not a +3. We're not right 3. We're now left 3. So our up becomes our left, and our left becomes our down, right? We just rotated this around. So we get our new X coordinate from the old Y coordinate, and we have to do the opposite. We don't want +3. We're not over here. We're left 3. So it's the opposite of our old Y coordinate is the new X coordinate. And our X coordinate is now the Y coordinate. However far left we were, -5, is now how far down we are on these. I know, it's crazy, right? It's very, very technical stuff. Now, last one, rotating 180 degrees about the origin. Notice this doesn't say clockwise or counterclockwise, because 180 is just halfway. It doesn't matter which direction you go, you end up in the same spot, and it actually looks the same either way that you rotate it. So if I rotate around, I'm going to tell you the coordinates this time and see if you can guess what it'll look like. We end up switching both, but the order stays the same. So instead of being left 5, I'm going to be right 5. Instead of being up 1, I'm going to be down 1. So this right here will be C prime. B prime, left 5, up 3 will be right 5, down 3. And then left 2, up 2 will be right 2, and down 2 is A prime. Oh, I went too far in B. So now B is down below C, and we can kind of see that if we rotate this picture around, right, B is down below C. Everything rotated around. And actually, our new sketch is where the old one used to be, because we're rotating it just 180 degrees around. You actually get this if you combine these two reflections together. If I flip over and then flip down, that's the same thing as rotating 180 degrees, is doing an X and Y coordinate reflection. Will get you to the same exact transformation at the end. All right, so I know that's a lot. It's super technical stuff for a pretty basic idea. You're just moving things around. So at the very least, make sure you understand how the words describe transformations. And at the very most, hopefully you can figure out how this XY transformation business works. But like I said, at the very least, make sure you get this up here. So let's look at a couple in the other order. What if I give you the transformation and I need you to try to describe what happened? So see if you can pause the video and write down what you think happened on each one of these pictures. Was it rotated? Was it translated? Was it moved? Was it reflected? And try to be as specific as possible and write down what you think happened on each one of these. All right, so this first one was definitely a translation. If you look at it, every one of these points moves from F to F prime, G to G prime, Y to Y prime by going down 1 and over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. So we can describe that as saying each point X, Y goes to an X value. X is left and right. X is 1, 2, 3, 4 more. So X plus 4, and Y minus 1 because we went down. So if you go down, you're subtracting. If you go right, you're adding. If you go up, you're adding. If you go left, you're subtracting. Keep in mind, positive is up or right, negative is left or down. So that would be the technical way of writing this statement right here. You should definitely be able to write this and work on trying to get this. Next one was rotated counterclockwise, the opposite way that a clock moves from here. So this is important to make sure you watch which one has the prime little tick marks on it. We start here and we rotate it to here. It didn't go from here to there. You always start here and go to the one with prime on it. Same thing back here. I knew to go down and left, not up and, down and right, not up and left, because these had the prime tick marks on them. So I was moving from here to there. Anyways, so when I rotate 90 degrees about the origin, I'm going from here to there. And when you do that, you're making your X, Y coordinates go to, let's see, I was left 1, 2, 3, 4. So I was at -4, 0 was my coordinate. And now Z prime is at 0, -4. So they swapped, and let's try this one right here, -5, -2, and now I'm going to be at +2, -5. It was hard to see on that first one because 0, you can't see the opposite, but see how we were down 2, and now I'm right 5? That negative went away to a positive. So I'm getting the opposite of my Y value and keeping my X value, but they're swapping spots. That's what happens when you rotate, right? That was the same thing when we looked at rotating 90 degrees counterclockwise on the front, 90 degrees counterclockwise, they switch and the Y changes its sign as it's now the X value. All right. Whew, hang in there. Reflected across the X axis, right? So the things that were up are now down. The things that were down are now up. Everything just flip-flop spots. There was no rotation here. It was just a reflection across the x-axis. And we show that by saying that our x, y coordinates, the x values stay the same, and we switch our y value. If you were down, now you're up. If you were up, now you're down. That's changing the y value. And then this one was like that last example I pointed out. You could either say rotating 180 degrees, or you could see it as a double reflection, reflecting over here and then reflecting down here. Right? Over and then down. Like just think about point X. It would reflect over to here and then down to here. Right? So that is two different options. If you were going to say rotating around, well, actually, either way, you would take your X, Y coordinates and they just both change signs. The X's go negative and the Y's go negative. I was left 1, 2, 3, 4 and up 2, and now I'm right 1, 2, 3, 4 and down 2. So the order doesn't switch, just the signs of both of those. All right, last one. So a triangle is constructed by the following points. So let's start by plotting. Let me zoom out here. All right, triangle is constructed by those 3 points. So left 2, up 3 is point A. Right 1, down 3 is point B. And right 4, up and down 0 is point C. Triangle A prime, B prime, C prime. So the triangle after I transform it is created by reflecting the triangle across the x-axis and then shifting everything up. So we're going to do two things. We're going to reflect across the x-axis, and then we're going to translate. We're going to move the points after we reflect. So let's see if we can do all that and find out where the final coordinates end up. If I reflect, if you want to pause and try to do it yourself, feel free to do that now. Otherwise, I'm just going to roll right on through. So if I reflect across the x-axis, what was up is now down, what was down is now up. So this would go, instead of up 1, 2, 3, I'll go down 1, 2, 3. So this is kind of a temporary point. So it's not A prime yet. We're not done with it, but we're on the process. That's after the reflection, but I haven't translated it yet. So I'm not quite done. This is down 1, 2, 3. So now it needs to go up 1, 2, 3. So this is kind of a temporary holding spot for B. And this is on the axis. So when I reflect it, it's just there. It doesn't go, it was up or down 0, so now it's up or down 0. It just stays right there. But I now need to move all of the points up 5 and left 3. So from here, I go up 1, 2, 3, 4, 5. Ooh, almost back to my starting point. And that is where A prime will be. From here, I go up 1, 2, 3, 4, 5. And that is the final resting place of point B. And from, oh, no, it's not. I got to move left. Mucho lo siento. Up 5 and left 3. Up 5 and 1, 2, 3. That's the final spot for A. Up 5 and left 1, 2, 3. That's the final spot for B. And up 1, 2, 3, 4, 5 and left 1, 2, 3. That's the final spot for C prime. B prime, A prime. Make our triangle. And that is what it would look like after doing both transformations. Reflecting and then transposing. These are still equal triangles. They have the same exact side lengths, angles, area, everything. They're just in a different location. And we could write out how to do that, but I'll leave that up to you if you want to try and check with me later. Whew! So that is transformations. You've got some practice to do on these. Make sure you try to work out these details. That will be like the 90 to 100% stuff on your test, is being able to make sure that you not only can you verbally describe what's happening, but use coordinates to do the same. So, but in some practice, and let me know when you need help.